Let's finish off what we started yesterday. Remember, we say for any non-zero real number A and any integers N and M, this is coming from, do you still remember that section that is dealing with exponents? Okay, that is coming from there. We are saying same basis. In number A, we are saying same basis, add exponents. You all still remember that rule, eh?
Yes.
Thank you. Number B is division. Still same base, then we subtract the exponents. Number C, base, multiplying the exponents, we just multiply the exponents. And then any number to the power negative is the same as 1 over that number to the positive exponential of that number. Are we clear on that? Any question on this slide? No. Okay, let's continue. Now, based on the previous slide, let's look at these examples. We're saying a to the power 5 over 3 is the same as, 8 to the power 5 over 3 is the same as 2 to the power 5. Why? Is it clear why we are saying why we are writing 2 to the power 5?
Yes, because you would cube the 8 to get 2.
Okay, thank you. As long as everybody can see that, then 81 to the power 3 over 4 is the same as the cube root of 3. The very same, we apply the very same principle as we did in the first example. Any question on number 2? No. Thank you. Let's continue. Now, in less than, how many are these? Okay, these are 5. Please do 1, 2, and 3 at once. I'm giving you 2 minutes. 1, 2, 3 at once. We'll check them at once. Tabang?
Yes, sir. Yes, sir.
What did you get for number 1?
3 cubed, which is 27. Then the second one is 4 to the 5th power, which is 1024. The third one is 2 squared, which is 4.
Okay. Let's start. The first one is
3 cubed. So should I give you all the steps or just the final answer?
Just the final answer. And then the second one?
It's 1024, which is 4 to the 5th power.
1024.
Yep.
And the third one?
2 squared, which is 4.
4.
Yeah.
Please ask them whether they agree or not.
Guys, do you agree?
Yes, I agree.
Yeah, I agree too.
I agree too.
Thank you. Now, let's now do 4 and 5 at once. What is the answer to number 4?
So 16 to the 3/4, it's we say 16 to the 4th root of 16. That's 4, and 4 cubed is what? 64.
Is your answer 64 for number 4?
Yes.
Okay. Number 5, Emmanuel.
Okay. The square root of 25 is 5. 5 to the 5. It's big number. Oh. It's 3,125.
3125.
Yes. Sorry, I don't have a calculator, so I'm just trying to use my head.
Ask them whether they agree with you on number 4. You said number 4 is 64, and then you
Yes.
said number 5 is 3125. Please ask them whether they agree with you or not.
Do you agree with me, gentlemen or ladies?
Yes, bro, we do agree with that.
Not a number.
No, I don't agree with number 4.
I also don't agree with number 4.
I have a different answer at number 4.
Emmanuel, talk to them. We must end with the same answer.
What's the 4th root of 16, guys?
It's 2.
It's what?
The 4th root of 16 is 2. So it's 2 cubed, which is
Okay,
8.
so the answer is 8. Yes, it's 8.
Emmanuel, what is your new answer now?
It's 8.
8. I'm writing 8 here. Then ask them whether they agree with 8 or not.
Yes,
do you
we
agree
agree.
with 8, guys?
Yes.
Yes, we agree.
Yes, we do.
Thank you very much. Now, we are starting to focus on the concept of limits. So we are done with that first section that we were dealing with. Functions and models. Any question on functions and models? No. Okay.
Yes, sir.
Thank you.
Just one question.
Yes.
So, sir, am I right to say we can always choose to start maybe with the denominator of the exponent? So let me give an example with, let's see, with number 5. Say with number 5. With number 5, I know that the numerator 2, it means I can find the square root of 25. But I also know that the denominator 5 means that I can find 25 to the power of 5. So can I start with whichever one makes life easy for me?
Who's talking? Is it Chanda Pio?
Yes, it's Chandapiwa, sir.
Chanda, what are you saying?
I'm asking if I can choose whether I want to start with the denominator or the numerator, or is the rule of thumb that I should start with the numerator first of the exponent.
Are you focusing particularly on number 5?
Yeah, just number 5, and any of the other question if it's possible.
Yeah, any, because they are just the same. Okay. Now, Chanda, help me out here. Ne? Do you still remember how we handled exponents in high school?
Yeah, clearly, I believe.
Hmm?
Yes, I think I remember.
Okay. Now, if you remember, let's just take, for example, let's just take number 5. Okay?
Yes.
We agree that 25 is 5 to the power 2. Ne?
Yes.
Now, okay, let me put it simply in this way. 25 is the same as 5 to the power 2. Okay?
Okay.
Now, that 2 is over 1. Do we agree?
Yes.
I'm referring to the 2, that is an exponent.
Yes.
Okay. Now, Let's look at the exponents, u and I. Let's forget about the 5. We have got 2/1 and 5/2 as the exponents, okay?
Yes, yes.
When we look at those two, you just see that 2 and the 2 will cancel, and then we'll just be left with 5/1, which leaves
Yes,
us with 5 to the power 5.
yes.
Mm.
So if I'm understanding you correctly, whenever we're doing any questions with exponents, the first step should be to prime factorize. Okay.
Now, let's continue with limits. Then when we are done with limits, then we'll go to derivatives. Okay. From now on, you and I will be dealing with this. Are we together? Now, there is the introduction to the concept of a limit. Now, I'll just be learning objectives are straightforward there. Use the correct notation, description of a limit of a function. I'm not going to go there. Now let me go away. Page 153. Okay. Definition of a limit. I say, let f of x be a function defined at all values. This is not your textbook, no? Let me say that in advance. Let f of x be a function defined at all values in an open interval containing a, with the possible exception of a itself. And let L be a real number. If all values of the function f of x approach the real number L as the values of x, which is not equals to a, approach the number a, then we say that the limit of f of x as x approaches a is L. Symbolically, we just say the limit of f of x as x approaches a is equals to L. Any question on this definition, straightforward definition? It might not be straightforward to others. Okay. Now, let's look at example 1B. An example. Let's look at this example. Evaluating a limit using a table of functional values. Evaluate the limit of the square root of x minus 2 all over x minus 4 as x approaches 4 using a table of functional values. Those are all the values as x approaches, meaning you just take these values, which are just almost 4, put them wherever you see x in there. Those are the values that you get. Any question on this? They're saying, as before, we use a table. In this case, this is a table to list values of the function for the given values of x. Any question on this example? Let's go to definition on page 160. Now, this is our Bible going forward. Definition of one-sided limits. We define two types of one-sided limits. Limit from the left. We let f of x be a function defined at all values in an open interval of the form z. And let L be a real number. If the values of the function f of x approach the real number L, as the values of x approach the number a, then we say that L is the limit of f of x as x approaches a from the left. And symbolically, we express this idea as the limit of f of x as x approaches a from the left with that minus sign. That means x is approaching a from the left, which is equals to L. The limit from the right, we say, let f of x be a function defined at all values in an open interval of the form a and c. And let L be a real number. If the values of the function f of x approach the real number L as the values of x approach the number a, then we say that L is the limit of f of x as x approaches a from the right, symbolically being f of x as x approaches a from the right equals to L. Any question about this definition? Let's look at example 1.24. Evaluating one-sided limits. For the function f of x is equals to x plus 1. If x is less than 2, x squared minus 4. If x is greater than or equals to 2, evaluate each of the following limits. The limit of f of x as x approaches 2 from the left. Let's look at this diagram, which one is this x plus 1? Is this straight line? Do we agree?
Yes.
When x is less than 2. And then this other one coming from the top, resting at 2, is the quadratic x squared minus 4, where x is greater than or equals to 2. Now, f of x, when x approaches 2 from the left, which one between the two, x plus 1 and x squared minus 4, are we focusing on when we are talking about the limit of f of x as x approaches 2 from the left?
Linear one.
The linear one. I
Yes.
agree. Now, that is number A. Now, which one are we referring to when we are talking about the limit of f of x as x approaches 2 from the right?
Quadratic.
Quadratic. Thank you. Now, take 2 and put it in linear as x approaches 2 from the left and tell me what you get.
3.
Alison,
Yes.
I can hear you that you are talking, but I didn't get that.
3.
I'm saying, oh, 3.
Yeah.
Yes, this is the one. Oh, this. Oh, okay, that is what you are referring to.
Yes, yeah, but you can see it on the graph as well.
I don't know whether everybody can see that or not.
Yeah, we can see it.
Oh, okay. Even for the limit of f of x as x approaches 2 from the right, to say it is, in fact,
0.
0. Do we all agree?
Yes.
Yes.
All right. Let's go to page. Where were we? We're now going to page 161. We're going to look at two-sided limits, the definition. What am I saying here? One-sided and two-sided limits on page. Oh, this is what we are looking for. It's just a relation, one-sided and two-sided limits. They're saying, let f of x be a function defined at all values in an open interval containing point A, with the possible exception of A itself, and let L be a real number. Then the limit of f of x as x approaches A is equals to L. If and only if the limit of f of x as x approaches A from the left is equals to L, and the limit of f of x as x approaches A from the right equals to L. Okay, this is what we are saying. In simple terms, we are saying the limit of f of x as x approaches A equals to L only if and only if the limit of f of x as x approaches A from the left is equals to the limit of f of x as x approaches A from the right. That is the condition that has to be met or to be satisfied. Example 1.25. Let's look at this example. Evaluate each of the following limits, if possible. If possible, use a table of functional values and graph f of x, which is equals to 1 over x, to confirm your conclusion. Now, please help me out here. Okay, let me do this. Yeah. I'll just pick randomly the limit of 1 over x as x approaches 0 from the left. Erica.
I'm here.
Okay. What is the limit of 1 over x as x approaches 0 from the left? In number A, that's number A. Do you see this example?
Yes, I see, but I'm still a bit confused.
Chanda?
I was offering to help, but I was first giving you a chance to guide her before I can offer any help, you know. Give her a chance to make mistakes too.
Oh, okay. Let's ask Chanda to help out. Chanda?
By helping out, am I giving the answer? Am I explaining the answer?
Whichever way that will
best.
make, whichever way that will make Erica to understand.
Okay, okay. So I think maybe from high school, you know, we're used to limits being like being the gradient, you know, finding f prime and so on. So I think what Erica must understand is we are looking for what is the limit of this function as x approaches that value there from the left. So when we're approaching 0 from the left, it means we're coming from negative infinity and we're coming towards 0. So what is the limit? So the limit is the value when that function is equals to 0. We're trying to find out what is it approaching as it's approaching 0 from the left. So to find that limit, what we can do is we can plug 0 into the function. But what is the function we're dealing with? The function we're dealing with here is 1 over x. So the question is, what is the limit of this function as x approaches 0 from the left? Let's plug in the 0. So I'm going to ask Erica to give us the answer. What is the answer when we plug in the 0?
Will it be undefined?
Yeah, beautiful. So the limit of this function as x approaches 0 from the left, coming from negative infinity, coming towards 0, that limit is undefined because at 0, you can't define 1 over 0 or anything divided by 0. So the correct answer is undefined, I believe.
Thank you very much. Now I understand.
So it's a value, or think of it as a y value, not a gradient.
Thank you, Chanda and Erica. Let me ask Chanda and Erica again to deal with number B. And then Erica and Chanda, after you have dealt with number B, then you are going to ask one person to give an answer. You two, you will decide who to question, who to ask to give us an answer to number C. Now you can go ahead.
I'll let
give
the
us an
lady
answer
decide.
to number B.
I'll let the lady decide who we're going to ask to give us the answer. I'll just give the explanation and Erica will give the answer and she'll choose who's going to ask the next question.
All right.
Okay.
Now
So with the,
you two now give us an answer to number B.
So with the other one, similarly, we have a Cartesian plane. We are imagining we have a function. We are substituting values that are becoming smaller and smaller and smaller and smaller, but they're coming from the right of 0. So they're coming from positive infinity and they're approaching 0. So we start with 0, 0.9, 0, 0.009, 0, 0.0009, 0, 0.000009. Now these values keep on becoming smaller, and the limit for those values, they cannot become whatever the value is when we substitute 0. So Erica is going to tell us what that answer is.
If I understand it correctly, it's also undefined.
Okay, so the limit for this function also is undefined. I believe that's also the correct answer.
Yes.
Thank you. Now you two, then you decide who should give us an answer for number C. Please choose.
Is there anyone that wants to tell us? Alison, maybe?
Well, so then my question would be, if both coming from the left and coming from the right are undefined, would this function exist?
Alison,
Yes.
your question?
A very nice question.
Because they both equal
Interesting.
undefined. So it's like, does it exist or not?
Very interesting. Hmm. Hmm.
So I'm going to
Yeah.
throw the ball back. Because I'm genuinely curious.
Can I have a go at this one?
Yes.
I think the best way to answer any question is using knowledge that you already have, you know? So
Yes, it would be then.
you know, with hyperbolas, those funny looking graphs that are on either side, the hyperbola. So the hyperbola has a point where it's undefined, and we call it the asymptote, right?
Yeah, that's
So it's undefined at that point because the denominator will be equals to 0. So because the hyperbola has a point where it's undefined, does it mean the hyperbola does not exist?
okay. So then would the asymptote be at 0?
I assume so.
Yes, Magwen.
Saying I want to answer number B. The limit from the left is not equal to the limit from the
I can hardly hear you, Magwen. You're breaking.
right. So the limit of x as approaches 0 does not exist.
Magwen.
Because we are dealing with two limits, and then the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the left. Yeah.
I'm battling to clearly hear Magwen. Can anyone hear her?
Yeah, she's saying the limit as x approaches 0 from the left is not equals to the limit as x approaches 0 from the right. Therefore, the limit of this function at x as x approaches 0 does not exist.
Okay, that's how we are concluding. Eh? The limit for number C, we are saying this limit does not exist. Can we all hear you? Can you all hear me?
Yes.
It doesn't exist because A, undefined, B, undefined. Now, that one, C, if A and B, we are saying for the limit to exist, we are saying for the limit of f of x as x approaches A from the left must be equals to the limit of f of x as x approaches A from the right. Therefore, the limit exists. So this limit, we are saying it doesn't exist. Is that how we are concluding? Is that our conclusion? Someone is talking.
Okay, I was saying the limit does not exist.
Thank you. We heard you. So this limit, okay, now number A. It's infinity from the left, B infinity from the right. Therefore, this limit doesn't exist. We all agree. We agreed long time ago about that. Eh?
Yes.
Yes. Now, that was, this was 1.125. That was 125. Now we are going to page 165. I'm now sitting in the dark due to load shedding, but at least you can all still hear me, né?
Yes, we can.
Thank
Yes,
you.
we can.
Now let's go to page 165, where we are going to talk about what you have already spoken about what I'm about to talk about. Chanda, you already explained this. Are you aware of that?
It's a gift, sir.
Eh?
It's a gift.
Okay. Vertical asymptotes coming from those functions that you have already explained, Chanda. There is another, with this change of codes of these modules, 1510. Yeah, I think it's 1510. That's where you will mainly be dealing with this. But now, let's look at what this definition is saying. Let f of x be a function. If any of the following conditions hold, then the line x equals to a is a vertical asymptote of f of x. X equals to a. It's a vertical asymptote of f of x. Therefore, the limit of f of x as x approaches a from the left is equals to what? Positive infinity. The limit of f of x as x approaches a from far left. This is a mistake. The first one should be positive. Do we agree?
Yes, we do.
And then the second one, x is approaching a from far left, as Chanda has already explained to us, is negative infinity. Now the limit of f of x, as x approaches a, from the right. What are these? Something is not making sense here. Let's look at this definition from the last one. We are saying the limit of f of x as x approaches a is equals to negative infinity. The second one from below, the limit of f of x as x approaches a, positive a, is equals to positive infinity. Now, the limit of f of x as x approaches a from the far right is equals to negative infinity. Let me, I'll go one step up, then we'll be able to clarify this. The limit of f of x as x approaches a from the right is positive infinity. The limit of f of x as x approaches a from far left is negative infinity. While from far, I'll tell you. Maths is about pattern. A pattern. Let's look at the last two in this definition. Do you see them?
Yes.
The last two.
Yes, we see them.
1.2, 1.2.23, 1.2.24. Do you see these two, these last two?
Yes.
Now let's look at the two in the middle again. And then the first two 19 and 20. I'm trying to look at the pattern. Is everybody following these 6 equations, or is there anyone who is confused? If you are confused, don't worry. It will become clearer with the examples that we'll be dealing with. Are we okay?
Yes.
In most cases, okay, let me close this curtain. In most cases, you will find that the definition in other cases, some of the people tend to be what? Not to understand the definition, but tend to understand the application. But if you'll still be confused, we'll always come back to the definition. Don't worry much. Now, let's go and look at exercise 1.2.5. This was the example. Here is the exercise. It says, evaluate each of the following limits, if possible. Use a table of functional values and graph f of x, which is equals to 1 over x squared, to confirm your conclusion. Without wasting time, we dealt with that example is almost similar to this exercise. This is the limit of 1 over x squared as x approaches 0 from the left. Now, as I said, do you all see number A, the answer to number A?
Yes.
Now, let's go to that definition. Let me ask you in this way. We were here, né? For us to get here, let's come back here. Infinite limits, because that's where all these have actually been summarized in there. They say we define 3 types of infinite limits. Infinite limits from the left. Let f of x be a function defined at all values in an open interval of the form BA. Number 1, if the values of f of x increase without a bound as the values of x approach number A, then we say that the limit of did I be reading all this? I'm just only going to be focusing on the equations. This is what we are saying. We are saying the limit of f of x as x approaches A from the left is equals to positive infinity. We all have that.
Yes.
Where x is less than A. Now, number 2, where x is less than A again, the limit of f of x as x approaches A from the left is equals to negative infinity. In number 1, f of x increases without a bound. But in number 2, f of x decreases without a bound. That is the difference. It is decreasing, it is increasing. That's why we are having positive infinity, a decrease, negative infinity. That's how they arrived at that table below, which seem not to make sense, which I said it will make sense as we continue. Now here, if the values of f of x increase without bound, we're expecting positive infinity. Where there is a decrease, that's what we're expecting, negative infinity. And then for two-sided infinite limits, when it is increasing, we're expecting a positive infinity. If f of x is decreasing, we're expecting a negative infinity. Where all these have just been summarized. They've all been summed up here, summarized, coming up from the definition above there. Example 1.25, is it what we did? Then the next one is exercise 1.26. Is it exercise or example? Let me check, clearly check it. Should be example. On my other note, on my notes here, it says 1.26. Finding a vertical asymptote. It says, evaluate each of the following limits using equations 1.2, equations 16, 17, and 18. 16, 17, and 18 are these 16. Where is 16? 16, 17, and 18. These are the three that we are requested to use. 16 says 1 over x minus a to the n as x approaches a. Equals to positive infinity. And then it goes further to say the limit of 1 over x minus a to the n as x approaches a from the far right. It's positive infinity again. But 1 over x minus a to the power n as x approaches a from the far left, it's giving us negative infinity. Now let's look at this example. Let's look at number A. Number A is the limit of 1 over x plus 3 to the power 4 as x approaches negative 3 from the left. What do we get when we put negative 3 in the place of x in number A?
We'll get 0.
We get 0.
Yes.
And listen, you're making that mistake again.
Negative 3
Sorry?
plus 3.
Negative 3. In the place of x, we are putting minus 3. What do we get? In the numerator, in the denominator, I mean.
0.
0. Now, if we get 0, then do we agree that our answer will be? Okay, look at it from this angle. In the bracket, we have got x plus 3 to the power 4. Okay. Now take what is inside the bracket. We're looking for an asymptote here. X plus 3 equals to 0. What is the value of x?
Sorry, could you repeat all that because you broke up there?
I'm saying, do you see the denominator?
Yes.
Focus on what is on the bracket, what is within the bracket. inside the bracket, you have got x plus 3. What I'm saying is to say, take what is in the bracket, equate it to 0. We'll have x plus 3 equals to 0. Then we solve for x. Do we agree?
Yes, x will be -3.
X will be -3. That will be our asymptote, our vertical asymptote. Do we agree?
Okay, yes.
Probably the example that I've chosen, maybe it is not a good one, or they are not the good ones. I don't know. No. The vertical asymptote here is -3. In here, the vertical asymptote is going to be 2, positive 2. And then what will be? Let me see. I want to see something. I'm still with you. Leave out this example, leave out this. I will check some, because these exercises have to be similar to those in your study guide. It doesn't mean that everything in the textbook, all the sections are the sections that are covered by your textbook. That's why sometimes, even when I pick the examples, I pick those that are similar to those in the study guide. So don't get confused. I think what I've been looking at, it is not what is actually in your study guide or even in your syllabus. Let's look at page 182. Is it 182? Yes. It doesn't mean that all the sections in the book are covered in this module. Some of them are not relevant to this module. That's why you see me choosing limit calculations for algebraic expressions. Let's see here. 132A. Where are we? Limits, calculations for algebraic expressions, evaluating limits with limit loss. Limit of x as x approaches a, it will just be a constant. Limit of c as x approaches a, it will just be a constant. This one is straightforward. Is the application of this. The limit of x as x approaches 2 will just be this constant. The limit of 5 as x approaches 2 will just be 5. Now, the limit loss. These are in your study guide. For the sum, the limit of f of x, the limit of f of x plus g of x as x approaches a is the same as the lim of f of x plus lim of g of x, which is equals to L plus M. The difference is the same. The lim of into f of x minus g of x is equals to the lim of f of x minus g of x, which is equals to L minus M, exactly as in your study guide. Constant. The lim of a constant times f of x as x approaches a is the limit of f of x as x approaches a times that constant. Now, this is the product. The limit of f of x times g of x is the same as x approaches a, is just the product. The quotient, the lim of f of x over g of x is the same as the lim of f of x over the lim of g of x as both approaches a. The power the square root. Now let me, yes, these are covered in the module. Let me check example 132. Not everything is covered in this syllabus. Now, use the limit laws to evaluate the limit of 4x plus 2 as x approaches minus 3. Let's apply the limit laws. The limit laws. So this will be the lim of the application of addition. This one. This will be the lim of f of x as x approaches minus 3. The lim of 2 as x approaches minus 3. That 4 is a constant. In the place of x, we'll just put minus 3. There is no way that we can put a minus 3 there. There it remains a 2. Then our answer remains to be minus 2. Is it making sense? Yes or no?
Yes.
This is the application of this law. This law. Number 1, the sum law for limits. Okay, now let's look at 32b. Use the limit laws to evaluate. This is part of your syllabuses, even within your study guide. The lim of 2x squared minus 3x plus 1 all over x cubed plus 4 as x approaches 2. How is this dealt with? This is the lim of the numerator divided by the lim of the denominator. Now applying rule number 1. This is how our numerator will look like. Applying rule number 1, this is how our denominator will look like. Then simplifying, we'll end up having this. Are you still with me?
I've got a
Or
question.
are you lost?
I've got a question.
Yes.
Do you have to separate, always have to separate out the coefficient from the variable? Like, for example, you've got, instead of 2x squared, it would have to be 2 multiplied by lim x squared. It can't just be.
Please.
So what I'm asking is, do you, when we're working out and we're doing, showing our work, do we always have to separate the coefficient from the variable?
Oh, I see what you mean.
Like they've done there.
With me making your work, I won't have any problem. I will not have any problem. But as long as I'm able to keep consistent, I'm able to keep track of what you are doing.
Okay.
I'll start to have a problem once I lose track.
Okay. All right. Cool.
Have I answered you?
Yeah. So pick one, keep it neat, and stick with it.
Aha.
Okay. Cool.
Yes. If you don't want to apply it the way it is, as long as you are understanding it and it is in your head, then there is no problem. Because at the end, we'll end up having the very same answer.
Yeah. Okay. Cool. All right. Thank you.
Thank you. Now, can I maybe some more examples. Let me see from, because I know which one was this. Before we get to the exercises, I'll tell you this one was 1-3. Let me write down here 1-3-2b. We need to do some more exercises. Now example 1-3-3. Example. Okay, this is the division. Example 1-3-3. Okay, this is how it goes. The lim of 2x squared minus 3x plus 1 all over 5x plus 4 as x approaches 3. Alison SU asked whether you do it the way they did. For me, it doesn't matter as long as you keep track of what you are doing. The most important thing is that we need to do is to simplify. People, are you still with me?
Yes, sir, we are there.
Yes, we're still with you.
Yes, we are here.
I just can see that it's a matter of substitution, substituting the limit to which it's approaching.
I agree. Okay, let me give you this advice. If an expression can be written into factors, please write it in terms of factors and then simplify. But if you cannot be able to write it into factors, then the only thing that you can do is just to substitute. Am I clear?
Yes, you are.
Yes, it's clear.
Thank you. That was 1-3-3. Let's look at this. I think this was an exam. This was an example. Now let's see what is coming. There is an exercise. Do you see this exercise? This exercise. Evaluate the lim of 3x cubed minus 2x plus 7 as x approaches minus 2. Please evaluate this. Or are you still lost? Yeah.
Please give us a few minutes to try and work it out.
Okay. Oh, yeah. Do you still need a few minutes to work it out? Yes, no? I've already by mistake revealed an answer.
Yes, we need time.
Yes, we need time working it out on the paper.
Okay. Now, did you all get this number?
Yes.
Did you all?
No, sir, I got negative 12.
You got negative 12?
Yes.
How did you get it, my brother?
I substituted 12. I substituted negative 2 into the function. I did f of negative 2.
Let me walk
Maybe
you
I
through
missed calculation. I don't know.
Is it Chanda?
It's Emmanuel.
Emmanuel. Okay. Now there is something that I forgot to mention. There are some of the exercises that have got errors, whose answers have got errors. So we need to double check all our answers. So we need not just assume them as they are on face value. There are a number of them that we are still going to encounter that are not what we are looking for. Emmanuel, did you say 3? Then you put the -2 and then you raise it to the power 3. You said
Yes.
-2, then you said -2, then you said +7.
Yes.
And then that becomes +4.
So
that
maybe I missed calculation. Let me try again.
That becomes -8. -8 times 3 becomes -24. And then -24, 7 plus 4 is 11.
Actually, it's
-24 plus 11.
It's -13.
-24 plus 11 is
-13.
-13.
Yeah, it's true. Yeah. I think I missed it when I substituted for x on the 2x there.
Okay.
Yes. Thank you. Thank you for that.
Thanks. I also got -13. Now that was 133. Now let's see, where do we go from here? Let's look at the next example. 134. This example, evaluating a limit by factoring and cancel. What do they mean by that? It goes back to what I said to say, if an expression has, if we are able to find factors for an expression, let's write that expression in terms of factors. If they do cancel, then let's let them cancel, and then before we substitute. In this case, we've got the limit of x squared minus 3x over all over 2x squared minus 5x minus 3 as x approaches positive 3. How do they do this? They say the numerator is the same as x into x minus 3. Do we agree?
Yes.
And then the denominator, the factors for the denominators are x minus 3 and 2x plus 1. Do we agree that those are the factors for 2x squared minus 5x minus 3?
Yes.
Do we agree? Okay. If we agree,
Yes,
then
because 2 times -3 is -6, so the factors are 3 and 2.
Okay.
And then, yeah.
If we agree, then the x minus 3 and the x minus 3 will cancel out. So we'll be left with x over
2x plus 1.
2x plus 1. Then we'll then substitute for x in x over 2x plus 1. When we do that, then our answer will have to be 3 over 7. Do we agree?
Yes.
Can we then attempt, is it a fair request for me to ask you to try this exercise 1.3.4?
Yeah, that's fine.
Yes, it is.
Okay, thank you. Please try it. Magwena, what did you get as an answer?
I got 1 over 3.
1 over 3.
Yes.
Please ask them whether they agree with you or not.
Do you guys agree with me?
I agree.
I agree.
Yes, I do.
Then the answer should be 1 over 3. Now let's see what we need to look. Now we are looking at example 134. Where is this? We're done, as well as the exercise. Now we are going to example 135. Where is it? Here is the example. Evaluating a limit by multiplying by a conjugate. Evaluate the limit of the root of x plus 2 minus 1 over all over x plus 1 as x approaches -1. How do we do that? Well, multiply by the complex conjugate of the square root of x plus 2 minus 1, which is the square root of x plus 2 plus 1, and simplify before we substitute. Complex conjugate of the square root of x plus 2 minus 1 is the square root of x plus 2 plus 1. We multiply throughout by that. We simplify. Then after that, whatever cancels out, we cancel. Then after that, we substitute. Any question?
Can I ask a really doff question?
Any question is welcome.
Because it's a term I haven't come across before, but what is a conjugate?
Conjugate. All right.
It's been a while
Now,
since high school.
Don't worry. Let's say we have got x plus, let's say we have got 1, as an example, né? Let's say we have got 1 over x plus 2. Okay? Then the complex conjugate of x plus 2 is x minus 3. I mean, of x plus 2 is x minus 2.
Okay.
The complex conjugate, let's say the complex conjugate of 25x plus 3 will be 25x minus 3.
Okay.
You just change the sign. If it is positive, another number takes the negative. If it is negative, the other number takes the positive. The conjugate of that.
Okay. So then, do we treat like things that are like underneath the square root as one variable, you could say, and then like, for example, in that example there, we've got root x plus 2 and then plus 1. It's only the 1 that would change.
Okay, Alison. Now, from high school, let's say the square root of 2 times the square root of 2. What is it?
Square root of 2 times the square root of 2 is 2.
It's 2.
Yeah.
Now, the square root of x plus 2 times the square root of x plus 2, what will it be?
Oh, it was x plus 2. Okay.
Yes.
Okay, all right, now that's fine.
Okay.
Thank you.
Okay, you're welcome. So is this making sense? Is this example making sense?
I think if we went through an exercise, it might become a bit more clear.
Yeah, but before we go there, this one must make sense before we go to the exercise.
I see other people have their hands up as well, so I'll let them ask.
Magwena and let me see. Magwena and Princess. Magwena, then followed by Princess.
Okay, so I just want to know that when we multiply by the, what do you call it, whatever it is, are we only...
Whoa. Not that language. No, Magwena, no.
Oh, sorry.
The conjugate.
Yes.
Yes.
Are we only changing the sign of the constant and leaving the x as the way it was?
You mean, are you referring to the term inside the square root sign?
Yeah.
Yes, that one, there is nothing that we can do to it. We can't do anything to this. Then the next one was Ngobile. Princess, yes?
Sir, I just want to ask, if we multiply with the conjugate, then we'll have a numerator and a denominator. Is it always going to be like that? Or is it because the one we've been given is something over something? How does it work?
Please be clearer so that I can be able to clearly explain to you.
So you see the limit.
In terms of your question, please be clear so that I can be clear in my explanation.
Okay, so you see the limit that we've been given, right? It's square root of 2x plus, it's square root of x plus 2, and then minus 1 over x plus 1. So
yes.
That is like, I'm asking if we multiply with the conjugate. So on the side, we have square root of x plus 2 plus 1, but over square root of x plus 2 plus 1. So I'm asking if that's always going to be the case, or it only applies when whatever we've been given is over something.
Oh, I think I hear you.
Yes.
It applies. Let's say, oh, let me check something before. Okay, now I see. I thought maybe you had already spotted something that I hadn't yet spotted. Let's say that x, let's say the square root of x plus 2 minus 1. Princess, let's say this equation. Do you see this? Let's say what you are given, evaluate the limit of the square root of x plus 2 minus 1 over x plus 1. Let's say it was inverted.
Yes.
Let's say the x plus 1 was the numerator and that other one was the denominator.
Mm-hmm.
We would still do the same.
Okay, so in that case, if it was invented, then the x plus 1 is the numerator, and then the square root is the denominator. That means we will multiply with x minus 1 over x minus 1.
Mm-mm.
Okay, I think I'm a little bit lost. That's why I was asking.
Okay, now the other thing that the next thing that you can ask is to say,
Mm-hmm.
why? Okay, I need to complex. Did you do, or are you registered for MAT1503?
No, not yet.
Because it becomes very much clear, this whole thing of conjugate is coming from complex numbers.
Okay, don't worry, I will just check it out. I'm writing complex numbers. I'll do my investigation on it, and then I think it will make sense.
Yeah, after your investigation, then do make the arrest as well. Ne?
Okay.
Don't only investigate. Don't only investigate. Please also arrest.
I will. Thank you, sir.
Okay, thanks. Are we all following? I mean, that is the technique. I don't know how many times can I say this. In maths, it can be whichever code, whether from this level, second level, third level, whether master's or doctorate. Then, of course, mainly postgrad, you'll realize that here we're just doing almost the very same thing but differently. If I can somehow try to explain to you what maths is. Maths is about checking for a pattern. A pattern. Let's say since we started here, we dealt with a number of exercises. But those exercises that we dealt with, they were different. But being different as they were each solved differently, one from the other. We did not solve them in the same manner. I don't know whether you follow me or not.
So far, so good.
We look at what we are given. Then we say to ourselves, okay, this is an example, this is an exercise that we are given. Oh, this is how we solve it. We look at another one, we say, oh, this one, but this one is different from that one. Then this is how we solve it. Then that's how we've been solving them up to this point in time. Okay. Then, also, the next exercise, all of us are going to work it out, but you will be the first to give us an answer. Is that okay?
No problem, sir.
Okay, thank you. Let's evaluate this limit. The limit of the square root of x minus 1 minus 2 all over x minus 5 as x is approaching 5. All right. Hey, Mazoso, what did you get, my brother?
Okay, sir. I got 1 over root 3 plus 2.
1 over root 3 plus 2.
Yes, sir.
Please ask them whether they agree with you or not.
Guys, do you agree with my answer, or does anyone have a different answer?
Yeah, no, the
I got a
mistake, I
different
got
answer.
one. I got 1 over 4.
I also got 1 over 4.
Okay.
I got -4.
-4, 1 over 4, and 1 over root 3 plus 2. We should have one answer. People, what's wrong?
Hi, it's maths. What can we say?
Oh, one of,
But we must
Alison,
still have the same answer.
whoa, sir, Alison and the other colleague is correct. I made a mistake along my calculation. So it is 1 over 4.
Is it 1 over 4?
I agree with 1 over 4.
Okay, I heard you. Now we are scratching out 1 over root 3 plus 2. Now,
Yes.
someone said -4.
That was me, sir. May I please have assistant? I don't know where I went wrong. It's Princess.
Is it Princess?
Yes.
Is it Princess?
Yes.
Please talk to her.
Guys, may I please have assistant? I don't know where I went wrong.
Did you multiply by the conjugate?
Yes, I did multiply by the conjugate, and then it gave me x minus 1 over x, okay, open bracket, x minus 5, close bracket, open bracket again, and then the square root of x minus 1 plus 2. Is that
So-
step fine?
The problem there, I think, is your the numerator, yeah.
My numerator.
Yeah, you made a mistake somewhere there because you should have x minus 5 in the numerator and exactly what you have in the denominator. So the problem is the numerator.
Okay. Okay, I'll try and work it
You
out
need some help with
again.
that.
Yes,
Please double
please.
check your process.
Yeah, I
Double
think
check
I
it.
lost it there, sir, because just as he says, I have something completely different. For me, it's x minus 1 as the numerator, then my denominator is x minus 5. Then on the other bracket is the root of x minus 1, then plus 2. So I think that's where I went wrong.
Princess, I'm not
Yes.
accepting your statement to say that's where you went wrong.
Mhm.
Okay. My
Should I
question
double
to
check?
you, yes, so that
Okay.
you fix that mistake.
Okay, I'm just gonna work on it again quickly.
Sir,
Hello? Yes? Can hear you?
it's Matsuso speaking. Do you mind if I add on to what we're just discussing right now?
Do I mind if?
Do you mind if
You
I
add.
share some light on what we are currently discussing? Because
Not
from
at
what
all.
she said, she got x minus 1 on the numerator. So when multiplying the conjugate brackets, especially on the numerator, you'd have x minus 1, meaning the brackets, they cancel each other out. The two middle terms also cancel each other out. What I could say she forgot was to multiply the negative 2 with the positive 2 for her to get a negative 4. Then her numerator was going to be x minus 1 minus 4, which would automatically turn to x minus 5. Then the x minus 5 that's on the numerator will cancel out the x minus 5 that is on the denominator.
Princess,
Yes, sir.
did you get that?
Yes. Thank you so much. I'm just still quickly working it out. As he said, I see what he's talking about. I didn't do that. So I got an incorrect answer.
Can I also suggest something?
Mm-hmm.
Yes.
I think to like cut things short, because I think in an exam you always want the fastest way or the simplest way or to learn the simplest way. When you have the square root of x minus 1 minus 2 close brackets open brackets square root of x minus 1 plus 2, I think you can notice there that it looks like a difference of 2 squares.
Mm-hmm.
So already when I do that step, I just know there's going to be a negative sign in the middle. There's going to be the first term squared. So what is x minus 1 squared? It's just x minus 1. There's going to be negative 2 squared. What is negative 2 squared? Is negative 4. Then I'll have x minus 4. So that you don't even have to expand the bracket. It's just a neat trick.
Okay. Thank you so much for that. Yeah, it makes sense. Yes, I got my answer.
Are you happy now?
Yes, I am. Thank you so much. Thank you, everyone. Thank you so much.
Do you see this number 1? Under
Yes.
exercise 1.3E.3, lim of x squared minus 16 all over x minus 4 as x approaches 4.
Yes, we see it.
Okay, you can have that one as an exercise. Copy it. After that, then you can tell me, then I'll look for another one. Copy these exercises, work them, make sure that your answers are as they are. If they are different, then we can talk tomorrow. We'll only talk about those who got different answers from what they got here. Then you can take a picture of 2, 3. No, let's see. 3. In this case, I'll request you to do number 3. Because it has got an answer, then you can be able to check. Did you take a picture of 3?
Yes. But I have. I'm waiting for the others.
Sorry?
I'm waiting for the others.
Or to take a picture?
Yeah. I've taken a photo. I just don't know if other people have.
Okay. All right. And then which one? You can also try number 8. And that will be the last one. Princess, if you look clearly, that exercise, there at the top is written answer. Do you see where they are using the complex conjugate?
Yes, I do, sir.
Uh-huh. Let's wrap it up here, then let's see each other tomorrow. Have a good night.